Okay, so what we've got here is lesson 3, which is advanced factoring strategies for quadratic expressions. So Carlos wants to build a sandbox for his little brother. He is deciding between a square sandbox with side lengths that can be represented by x plus 3 units and a rectangular side box with a length 1 unit more than the side of the square and width 1 unit less than the side of the square. Okay, so if you take a look over here, he says, okay, this is x plus 3, some unknown quantity x plus 3 units, and then some unknown quantity x plus 3. So this is a square sandbox. And over here, he said, okay, what if I add one side to this dimension and then take away one side from this dimension? So Carlos thinks that the area should be the same because 1 unit is just moved from one side to the other. So do you agree that the 2 areas should be the same? Why or why not? So what I suggest you do is pause the video, try and find it out, but I'm going to go over it here in just a second. Okay. So assuming you've had a go at it, I'm going to try this out. Area is equal to length times width, but my length is x plus 3. So I've got x plus 3, and then I've got my width is x plus 3. And if you remember from previous lessons now, right, I can do first term squared, so x squared, and then multiply these two, right? This is just x plus 3 quantity squared, so I'm just going to use an identity here. So just make sure. So that identity is 2 times these two terms, so 6x, and then that term squared. So x squared plus 6x plus 9. So this is the area of this first rectangle. So I'll do that in black, and then in the next one I'll do it in red. So we're going to try and find the area of this guy. Well, that's going to be x plus 3 minus 1 times x plus 3 plus 1. Now this is a difference of squares, so what we can do is multiply the first 2 terms, the last 2 terms, the inside terms, and then the last terms. Okay, so the first outside, inside, last term. So I misspoke there a minute ago. So x plus 3 squared, we just did that. So x plus 3 times x plus 3, that's going to be x squared plus 6x plus 9. Great. So then we have x plus 3, right, times positive 1. So that's going to be plus x plus 3. And we do the negative, so this negative will distribute to both of these terms, so that gives me a minus quantity x plus 3. So I've got a plus parentheses x plus 3 and a minus x plus 3. So those will cancel or add to be 0. So I don't want to exactly say cancel all the time. So the positive and the negative version of that will add to 0. Negative 1 times positive 1 is negative 1. So this is the exact same expression as we got over here, minus 1. So that leaves us with, I'll do it down here, x squared plus 6x plus 8. So they are not the same, and that's because there was 1 square unit lost in the translation, okay? So the first square sandbox has the most area. How would you write the expressions that represent the length and the width in terms of the side length of the square? Okay, so this is actually just doing exactly what I was talking about. So we found the area of both terms. So they're like trying to lead you to that. Okay, how can this expression be seen as the product of a sum and difference, a plus b and a minus b? So that's exactly what we saw up here, right? Whenever you multiply these out, this is a difference of squares, okay? So in this case, this is our a and this is our b. And this is our a and this is our b. So a minus b, a plus b, or the other way around. So they're trying to show you, they're trying to lead you there. So a through f is doing that. So can you verify that our algebra is correct using a diagram or a visual display? Well, let's say this was like the x term was 22, okay? So if this is x plus 3 and x plus 3, if x is 22, then that makes the side lengths 25 and 25. Well, 25 times 25 is 625, all right? So that first area of the rectangular, if x is equal to 25, if x is equal to 25, that area is going to be 625, right? But for the other area, right, I'm going to take one side length and add one and then subtract one from the other side. So this would make this 26, and this would make this 24. So if I do that calculation, right, I got 20 times 20 plus 20 times 6 plus 20 times 4 plus 6 times 4. That's what that is. So it's going to be 400. So 26 times 24 is what I'm trying to calculate. 20 times 6, that's 120. 20 times 4, that's 80. And then 6 times 4, that's 24. So if I add these up, 120 plus 180 is 200, so 624. So take a look. It's exactly one less. So you do lose some area if you actually like show what these regions are. So if you take some what if and questions, or what if scenarios. In lesson 2, we saw that factoring is a reverse process of multiplication. We factor a polynomial by reversing the distribution process. Consider the following example of multiplication. I've got x plus 3 times x plus 5. So if I distribute all this stuff out, I've got x times x, x squared, x times 5 is 5x, 3 times x is 3x, and then 3 times 5 is 15. Then they combine the like terms. It says when we compare the numbers in the factored form with the numbers in the expanded form, we see that 15 is the product of two numbers, 3 times 5, and 8 is their sum, 3 plus 5. The latter is even more obvious when we look at the expanded form before the terms are combined. So what it's saying is it's easy to see that these items, just like we factored by grouping earlier, you can easily see that 5 times 3 is 15, and then 8 is added from 5 and 3x. So this is multiplying to binomials. So whenever we factor, we're essentially dividing, which can get a little more complicated because it takes a little bit higher level of thinking. Now it says, now compare the expansion of this binomial. Well, it's a little more difficult because I've got 2 times x, which is 2x squared. I've got 2x times 5, which is 10x, 3 times 1, which is 3x, and then 3 times 5, which is 15. See, 10 and 3 don't multiply to be 15, but they add to be 13. So whenever we're talking about this type of quadratic and we're trying to factor it, that's why we look at the a times the c. Okay, so if you look at a times c here, I get 30. So there are no two numbers that add to be 13, but add, well, in this case, 10 and 13 add to be 13x. I mean, 10 and 3 add to be 13x. Sorry about all the misspeaking. So 10 and 3 add to be 13x, but they don't multiply to be 15. But they do multiply to be 30. So if your a is not 1, if a is not 1, and the quadratic is factorable, a is not 1, sorry, and the quadratic is factorable, then what you'll find is you have to use a times c to find how to factor the quadratic. So the split linear terms are different than the last two terms, and the reason is because there is an a term that is not 1. Okay? It says now we have 4 different numbers in each form of expression. How can we use the numbers in the expanded form of the quadratic expression on the right to find the numbers in the factored form on the left? Okay, so they're saying, okay, how can we get from this step backwards to this step? So how can we show that those two things are equal? And the reason the way how we do that is called factoring. So what we're going to do is we're going to take the first two terms, 2x squared plus 10x, and then 3x plus 5. And we're going to find the GCF from both terms. So if you take a look here, 2x squared and 10x have two things in common. They have a 2, they're both divisible by 2, and then I can factor an x out. So I'm left with x plus 5. Or, yeah, should be x plus 5. Oh, it's 3x plus 15. My bad. And then over here, these two terms, I can factor a 3 out. So I can factor a 3 out, and I'm left with x plus 5 inside those parentheses. So if this is the case, then x plus 5 and x plus 5 now match, and now they're a GCF. So I can take it, I can factor it out. Got x plus 5 and 2x plus 3, and I'm finished. It says now we need to place those numbers in parentheses. Okay, so this is exactly what I was trying to say here. So they were trying to, okay, so this is just a method that they're using to try and lead you to see. Now we need to place those numbers into parentheses for the factors. Yeah, we did factor by grouping. I don't think we need to go over that. So they're saying now try and factor a quadratic with some negative coefficients. Well, in this one, right, 3x squared minus 8x minus 4, I'm actually going to go over here. 3x squared minus x minus 4. Okay, so 3x squared minus x minus 4. So what we're trying to do here is we're trying to find two numbers, which I did this in a previous lesson, so you can take a look at that if you want to. 3 times negative 4 is a times c, right? Right, your a is 3, your b is negative 1, your c is negative 4, so a times c is negative 12, your b term is negative 1. So you're looking for factors of negative 12 that add to be negative 1. So if I go over here and I look at factors of negative 12, I've got 1 and 12, 2 and 6, and then 3 and 4, okay? So I'm going to use this notation, plus minus, minus plus, plus minus, minus plus, plus minus, minus plus. And all that's going to mean is, okay, in order to have a negative 12 multiply, the first two terms are going to have to be positive negative or negative positive. So if I add 1 to negative 12, I'm going to get negative 11. And if I add negative 1 to positive 12, I'm going to get positive 11. So positive 2 minus 6 is going to give me negative 4 here. Negative 2 plus 6 is going to give me positive 4. So hopefully you're catching on to the plus minus thing. So positive 3 minus 4 is negative 1. And then negative 3 plus 4 is going to be positive 1. So I'm looking for the b term that's negative 1, and the pair that works is positive 3 and negative 4, which is negative 1 over here, okay? So if that's the case, 3 minus 4 is negative 1, so I can split up that x term, and I'm going to use those factors to do it. So 3x squared plus 3x minus 4x minus 4. There we go. So that splits up our linear term. Then we want to group the first two terms and the last two terms. So make sure that you put parentheses around it, and then that plus sign, we talked about this, that's important. If you don't put the plus sign, you're saying that the two parentheses are multiplying. That's what you are implying there. So if I factor 3 out and x out, I'm left with x plus 3. And then over here, they both have negative 4, so I can factor a negative 4 out, and I'm left with, let's see here. No, it should be not x plus 3, x plus 1 is what that should be, right? 3 divided by 3 is 1, duh. So that's x plus 1, and then negative 4 factors out, so I'm left with x plus 1 over here. So x plus 1 and x plus 1 can factor out, so I'm left with x plus 1 out front. Then over here, 3x minus 4. And then if I want to, I can take that a step further and I can find the roots, and I can find where this thing hits the y-axis, set each factor equal to 0. And then x equals negative 1 and 4/3. Okay, so that's about it. So that's where that quadratic would hit the x-axis. Let's go back over here. That's 3x squared minus x minus 4. And so you can start to factor some of these just by using a times c, right? We've talked about a times c, but in the previous examples that we've done, the coefficient has not been 1. So here a times c is 3 times negative 8, which is negative 24. B term is negative 2. So I'm looking for two numbers that multiply to be negative 24 but add to be negative 2. And you might already see it, you might not, but if you look at factors of negative 24, plus minus 1 plus minus, or minus plus. Yeah, I need to put that as minus plus. Minus plus 24 plus minus 2 minus plus 12 plus minus 3 minus plus 8 plus minus 4 minus plus 6. Okay, so those are the factors of 24. So if I take a look here, 1 minus 24 is negative 23, and then negative 1 plus 24 is positive. 2 minus 12 is negative 10, negative 2 plus 12 is positive 10. 3 minus 8 is negative 5, negative 3 plus 8 is positive 5. 4 minus 6 is negative 2, and then negative 4 plus 6 is positive 2. And that's about it. So the pair that work is actually going to be 4 and negative 6. So you see that 4, positive 4, and negative 6 multiply to be negative 24, which is your a times c, but they add to be your b term. Okay, so that's what we wanted. We wanted factors of negative 24 or a times c that added to be b. So we found the two lists. So all we do with those two numbers, is we come over here and we split up this quadratic. So I've got 4x minus 6x minus 8. So I'm going to factor out the GCF. Now out of the first two terms, you'll find that there's no GCF in the integers. There's only a GCF in the variables. So these two variables, I can factor an x out. So I'm left with 3x plus 4. And then over here, these two have a GCF in the integers, right? I can factor out a negative 2. And I'm left with the same thing in the parentheses, 3x plus 4. So 3x plus 4 factors out, so I'm left with 3x plus 4 and x minus 2. Okay. So I'm going to do the same thing down here. What you'll notice is that these two problems are similar. So I don't even have to do the a times c step in the b term, because a times c is going to give me negative 24. I just have to find the two factors that add to be 10. And it's going to be a positive 10. So if I take a look here, the positive is on the bottom. So I need negative 2 and positive 12. So that's going to work out. So I'm going to go ahead and split up that variable term with negative 2x plus 12x minus 8. So if that's the case, now I can factor these guys out. So I can factor an x out of these two. There's no factorization in the integers. So 3x minus 2. And then these two are divisible by 4. So I can factor out a 4. I'm left with 3x minus 2. So then 3x minus 2 goes to the front. X plus 4 goes here, and we're done. Okay, this was going to be a little dicier, right? I've got 3 times negative 14, so I've got to figure that out. So it's going to be negative 42. So a times c is negative 42, and then your b term is 1. So if I go over here and find factors of negative 42, we're going to play this game again. So we've got 1 plus minus 1, and then minus plus 42. So that's going to give me what? Negative positive 41. Yeah. And then we've got plus minus 2 and minus plus 21. So that's going to give us negative 19 and positive 19. And then I've got plus minus 3 and minus plus 14, which is going to give us negative positive 11. And then let's see, I don't think it's divisible by 4. Yeah, it's not divisible by 4, so you can use your calculator to do this if you need some help with it. So it's not divisible by 5 because it doesn't end in 5 or 0, but it is divisible by 6. So plus minus 6 and then minus plus 7. So if you take a look here, 6 minus 7 is negative 1, and then negative 6 plus 7 is positive 1. So I'm going to take a look here. So negative 6, positive 7 is my pair, and it does add to be our positive 1b term. So we can split up the coefficients. So here we go, 3x squared minus 6x plus 7x minus 14, and then I can start to factor. So these two have a factor of 3, and then x, I can factor that out. Left with x minus 2, and then these two I can factor out of 7. So 7, x minus 2. So x minus 2 goes here, and then 3x plus 7 goes there. Okay. So 2x squared minus 21x minus 36. So, okay, so we don't have any of the... What? Why does Daddy have it? I'm busy. Okay, a times c is negative 36. I mean, a times c is not negative. That's silly. That's negative 72. So d is negative 21. And it says this one might be a challenge. If it takes too long, try the next one. We're determined. We are determined. So we're going to get some more space here, because they didn't give us enough there. So 2x squared minus 21x minus 36. Let me make sure. Yeah, that's it. Okay. So I can come over here, and I can start to factor this guy, right? I've got quite a bit of space here, so I can just take that a times c, and I can just, in my own little world here, I can find the factors of negative 72. I know it's divisible by 2, so I'm going to start there. So 72 divided by 2 is 36. So plus minus 2. Plus minus 72. Or negative plus. Negative plus. Negative plus. That's not working. Not working. Nothing is working. Okay. Negative plus 36. 2 minus 36 is negative 34. Negative 2 plus 36 is positive 34. So then plus minus 3. It is divisible by 3, which is 24. And we got our pair. Look at how hard that was. They're saying it's hard, but we got it. So 3 minus 24 is negative 21. Negative 3 plus 24 is positive 21. So I'm looking for negative 21. So I've got positive 3, negative 24, and then negative 21. So that's the pair that I need. So I'm going to split up that linear term, that variable term. So I've got, right, positive 3x here, and then negative 24 here, and negative 36. So right here, right, there's nothing that 2 and 3 are divisible by, right? They're prime, or co-prime. So I can take and factor an x out. So I'm left with 2x plus 3. Negative 24 and negative 36, they're both divisible by negative 12. So I can factor that out, and I'm left with 2x plus 3 again. So 2x plus 3, and I can't reiterate this enough, so I'm going to make sure that this is working. 2x plus 3 and 2x plus 3 are a GCF at this stage, right? They're written twice. They're multiplying these two terms. And so you can factor it out just like you factored that x out earlier, right? We factored an x out of these two terms, brought it to the front, decreased that power, got rid of that x, got 2x plus 3 here and x. 2x plus 3 is a GCF, so we can do that too. So we can write 2x plus 3 here once, because we factored it out of that expression, just to make sure. So it's going to get confused for a second. Likes to get confused whenever I switch between my pen and my highlighter. And I'm left with x minus 12. And that's it. That's literally it. That's all we have to do. So we are finished with that. And that is fully factored. So let's take a look at these. So this one's, it's a times c is negative 18. Negative 18. And then its b term is 3. So if I take a look over here, factors of negative 18, plus minus 1, minus plus 18, so negative 17 and positive 17, plus minus 2, minus plus 9. So then 2 minus 9, 7, negative positive, plus minus, and it is divisible by 3 as well. Lots of divisible by 3s today. 6. Yeah, so 3 minus 6 is negative, and then positive 3 for the bottom. So we're looking for positive 3, so our two factors are negative 3, positive 6, and then positive 3. So I'm going to split up that term, so negative 2x squared minus 3x plus 6x plus 3. So I can factor this guy out. There's a negative that factors out of these two and an x. So I'm going to factor that negative out in the x, but 2x plus 3 are not divisible by another number, right? I can factor that negative out, but not much else. And then these two guys, ooh, that's 9. That's not 3. Come on, that's not 3. Okay, so I can factor a 3 out of these two guys. So I can do that. So I got negative or positive 3. And then I've got 2x plus 3 is left. Okay, so it says this one has a negative on the leading coefficient. So I'm starting to see that now. So right, 2x plus 3 is a GCF. So we're going to go ahead and factor that guy out. So, right, we've got 2x plus 3, and then negative x plus 3. So what we can go ahead and do at this stage is this negative. We can divide this term by negative 1, this term by negative 1, and then bring the negative 1 out to the front. So I'm going to factor that negative 1 out of both of these terms and flip the signs. So from this line to this line, this negative 1 came out to the front. 2x plus 3 is not changed. But negative x plus 3, I've got positive x now. Negative 1 divided by negative 1 is positive x. 3 divided by negative 1 is negative 3. So that's the leading coefficient is what it was talking about. So here's that leading coefficient. It says we need to try one with fractions too. Oh, no, too hard. No, not doing it. I'm just kidding. Okay, let's do it. I'm looking for two numbers that multiply to be 9 over 16, but add to be 6 over 4. Well, I can take a look at this, right? 9 over 16. Right, what are some numbers that multiply to be 9 over 16? Well, plus minus 9 over 4 minus plus, no, it's plus. It's just plus. Plus and minus on the bottom. So let me get rid of that. So plus 9 over 4 and then plus 1 over 4 are both negative. But I'm only going to use the positives because my b term is positive, so I can do that. So these will multiply to be 9 over 16, but they will add to be 10 over 16. So I'm looking for the pair that adds to be 6 over 4. So let's take a look at here. What are some other numbers that I can split 9 into? Well, that's 3 and 3. And the 4 comes along for the ride. Now I know the b term is going to add up to be 4, so I know that 16 is going to be 4 and 4 here, so it gives me the factor of 16. So 4 times 4 is 16, but whenever you add fractions, the denominator stays the same, so I know that it's going to be over 4 when I add it. So that should be 10 over 4. That's my mistake. It was a silly mistake, but that's a mistake nonetheless. So here I've got 3 times 3 is 9, 4 times 4 is 16, so that works for multiplication. If I add it, it's 3 plus 3 is 6, and then 4 stays the same, so 6 over 4. So we've got a b term of 6 over 4 and a a times c term of 9 over 16. So what that tells me is I've got r squared plus 3/4 plus 3, that should be r, plus 3/4 r plus 9 over 16. So r factors out of the first two terms. In the last two terms, I can factor a 3/4 out. So 3/4 divided by 3/4 is 3 over 4. 9 divided by 3 is 3. 16 divided by 4 is 4. So over here, it's going to give me 1r plus 3/4. And then r plus 3/4 matches. So I can factor him out to the front. And then I'm left with these two terms in the next set of parentheses, which is just the same term, which is equal to r plus 3/4 quantity squared. For exercises 7 through 10, use the structure of these expressions to factor completely. So let's take a look at this, and we can see that it's going to be a nightmare. And we're going to hate ourselves for doing this, but we're going to do it 100 times 63. (6,300), negative 6,300. So a times c is negative 6,300. And then I look at my b term, which is negative 20. So I know that they're roughly close. So I know that 63 itself, right, it's divisible by 9. So 9 and 7. So if I think about this, let's see here. Is it 70, 90? Yeah. So if I take a look at this, I know 63 is divisible by 9. 9 and 7. So that means 6,300 is divisible by 7 and 9. So I'm going to try that. It's 70 and 90. So I'm going to try plus minus 70 and then minus plus 90. So 70 minus 90 is negative 20, which is what we need. Negative 70 plus 90 did not work, so it's positive 20. So if you look here, I can split that term up. I've got 100x squared, negative 90x, plus 70x, and then negative 63. So right here, out of the first two terms, I can actually factor a 10 out. So I've got 10x, so I can factor an x out. So 10x minus 9. And then over here, I know they're both divisible by 7. So I'm going to factor that 7 out, and I'm left with 10x minus 9 again. So then that completely factors out as 10x plus 7, and then 10x minus 9. And then we can get into this nice conversation about setting these guys equal to 0 and finding their roots, and we're going to do that. So we can do that. We can find the roots, the zeros, or the x-intercepts of these two parentheses, and we're going to do that. So if I take 10x plus 7 and set it equal to 0, I can subtract 7. I'm going to subtract 7. I'm going to get 10x equals negative 7. And then I'm going to divide both sides by 10, and then I'm going to get x equals negative 7 over 10. And then over here, I'm going to get something similar. I'm going to take 10x minus 9 equal to 0, and then I'm going to add 9 to both sides, and then I'm going to get 10x equals 9, and I'm going to get x equals 10 over 9. So that tells me that this quadratic, for some odd reason, it's negative 7 over 10 and positive 10 over 9. But he's a nasty one. Look at that thing. Look at that thing. Look at that thing. All right. And then we get into some more complicated ones, right? You might be staring at this and you might be thinking, well, what in the world is this? Well, we're going to cheat. We're going to let m be y squared. If I let m be y squared, then I'm going to replace all these y's with m's. So I've got y squared here, so that is m. So 2m, and then y to the fourth is y squared squared, right? If I square this side, I'm going to get to the fourth. If I squared this side, I'm going to get m squared. So that allows me to write m squared here. So what was hard before is now easy, right? If this is y squared and this is y to the fourth, then that's a quadratic that's hidden. I can let it equal m or j or whatever I want to, and then factor it. So a times c is equal to -3. B is equal to 2. So I'm looking at for factors of 3, which are pretty easy. Plus minus 3, plus minus, or minus plus 1. I'm looking for the positive version. So look at that. It's right there. Plus 3 minus 1 is positive 2. That was hiddly diddly. That was bad. Okay. M squared plus 3m minus 1m minus 3. Factor an m out of these two. We've got m times m plus 3. -1 factors out of those two. -1, m plus 3. M plus 3 factors out. So they factor out, so I'm left with m plus 3, and then whatever's left here is m minus 1. So that goes there. So then I have to ask myself, well, where are my two zeros? Well, what makes this 0, this factor 0, and what makes that factor 0? And the only two solutions that work are -3 and +1. And then we got this sucker. And always remember your step 0, right? Before, I didn't see a step 0, so I didn't mention it, but this step 0, if you watched some of my other videos, you should know that look for a GCF first. So if you take a look, 9, -3, and -12 are all divisible by 3. So I can factor a 3 out, and I'm left with 3x squared minus x minus 4. And that makes it much easier because my a times c is -12, my b is -1, and I've factored 12 before, so I'm kind of seeing that, right, plus minus 4 and minus plus 3 are what I need to look at. We've got a -1 contribution here, so I know 4 and -3 add to be 1, and that -4 plus 3 is -1. So what I'm going to do with those two things is I'm going to take -4 and +3 here and add them together to get -1. So that gives me 3 times 3x squared minus 4x plus 3x plus 3x minus 4. So now I can factor. So these two terms factor out an x. And then these two terms factor out a 1. And then 3x minus 4 factors out. So 3x minus 4, x plus 1. And then my two zeros are 3x minus 4 equal to 0. Add 4. Divide by 3. Take the other one. X plus 1 equals 0. Subtract 1. -1. And then we got this thing. Well, they're all divisible by 2. And then, let's see here. AB squared is a squared b to the 4th. So here we go again. We're going to cheat again. J equals, and I can come up here and actually redo that. So I'm actually going to mention something here. This m plus 3, this is not true. Sorry. That was my mistake. So m plus 3, whenever I put the m in to factor it, you have to replace it. So y squared plus 3. So that was my mistake. I remembered halfway through. So y squared plus 3, and then y squared minus 1 is what that is, because you replace the m at the end. So here we're going to have to replace this. So remind me, even though you're not here, remind me to replace that. Okay. So JAB squared, so that means J squared is a squared b to the 4th. And then every single number is divisible by 2. So I'm going to factor out a 2. and j squared. So that's going to be 16 divided by 2 is 8j squared. And then 20 divided by 2 is 10j. And then negative 6 divided by 2 is negative 3. So I'm looking for two numbers, and I bet you that's the first quadratic we factored, because they're kind of like that. That's the second quadratic we factored. So I already know how this is going to factor because we factored it before. That's 3j squared plus j, 10j minus 8. It's going to factor as 3j minus 2 and j plus 4. So we've done this before. So let me make sure. That was a negative 3 at the end, right? It's not a negative 3 at the end. I'm just off my rocker. I thought I was really close to cheating that one out, but I can't. I can't cheat it out. A times C is negative 24. Okay, A times C is negative 24. And B is positive 10. So if that's the case, I'm looking for two numbers that multiply to be 24, but add to be 10. Add to be negative 24, but add to be 10. So positive 2 and negative 12 or negative 10. Negative 2 plus 12 is positive 10. That's the bill. That is what we need. Negative 2 plus the 12. We're going to split this guy up. 8j squared plus 12j minus 2j minus 3. Out of the first two terms, I can factor a 4j out. Out of the last two terms, I've got 2j plus 3. Next two terms, I can factor a negative out, and that's about it. In fact, that is it. That is it. That's all she wrote. So 2j plus 3 factors out, so I've got 2 times 2j plus 3. And then the last two terms are 4j minus 1. And remember, we gotta put in that ab squared at the end, so here we go. 2 times 2ab squared plus 3, 4 ab squared minus 1. Perfect. So lesson summary. Quadratic expression. Polynomial expression of degree 2 is often referred to as a quadratic expression. Some quadratic expressions are not easily factored. The following hints will make the job easier. Difference of squares. A squared minus b squared. Either of these terms, a or b, could be a binomial itself. The product sum method is useful, but it can be tricky when the leading coefficient is not 1. Trial and error is a viable strategy for finding factors. Check your answers by multiplying the factors to ensure you get back the original quadratic expression. So some problem sets down here. Yeah. I recommend doing all the odds. All the odds. Boop, 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 boop. Yeah, those are good. Those are good. Those are tricky. Those are nice. And these. That'll help you factor. You'll factor great. So next time, advanced factoring strategies for quadratic expressions again. Get to do it all. And look. Yeah, it's doing exactly what I just did. So I don't think I need to cover that lesson. I think we're good. It's the exact same lesson. So take it easy.